All right, 61 looks like this. First thing I'm going to do is I'm going to factor the bottoms. So I'm going to say 1 over x plus 1 times x minus 1 equals 2 over. This thing's going to factor, looks like, into x and x. Looks like it's going to be 2 and 1. I'm creating a positive x, so it's going to be positive 2, negative 1. I need a common denominator here. My common denominator is going to be, looks like, x plus 2, x minus 1, and x plus 1. So now I got to figure out what's missing. Multiply the top and bottom by x plus 1, because that's what's missing from the right. I'm going to multiply the top and bottom by x plus 2, because that's what's missing from the left. So what I get is x plus 2. Now, once I get common denominators in an equation, what can I do with my denominators? Andres? I can get rid of all of them. So what I end up with is x plus 2 equals 2x plus 2. I'm going to go and subtract 2 from both sides. This is a piece of cake. X equals 0. Now check. Is it possible for x to equal 0? Because we can't have 0 in the denominator, right? What happens if we have 0 in the denominator? I start calling you Scott. All right, so 0 squared minus 1, I get negative 1, and then I get negative 2. I'm good. X can equal 0. Carly. I didn't get x equals 1.
I know, but like,
In another problem? Okay, what that means is that x equals 1. If you plug 1 into this denominator, 1 minus 1 is 0, and you got a 0 on bottom. That's a problem in the domain. Okay, you can't divide by 0, because then I start calling you Scott. Right? I don't know why that would even be an option. I didn't get x equals 1. I just got x equals 0. Okay. Yeah. No, looks good. Okay, I'm sorry, we did 61. So let's take care of 63. I imagine 63 is a similar problem. Okay, I'm going to factor everything. So this is 5x plus 2 over x plus 2 times x minus 2 minus 2 over x plus 2. Put that in parentheses just because. Now this problem here, I'm going to go ahead and do a couple of maneuvers. I'm going to flip them, and then I'm going to factor out a negative 1. Does that make sense what I just did? Flipped and factored out a negative 1. The negatives are going to cancel each other out, so that ends up being 5x over x minus 2. Now my common denominator is simple. It's x plus 2 times x minus 2. So I'm going to multiply the right side by x plus 2. Multiply the middle by x minus 2. So what I end up with is all this garbage is going to go away. And I get 5x plus 2 minus 2 times x minus 2 equals 5x times x plus 2. Let's go and simplify some of this. At 5x plus 2 minus 2x plus 4 equals 5x squared plus 10x. These can combine to become 3x plus 6 equals 5x squared plus 10x. Let's see, I'm going to go ahead and subtract 3x and subtract 6 from both sides. I end up with 5x squared plus 7x minus 6 equals 0. Factor that out. So this is 5x and x. I believe this is a 2 and this is a 3. Just kidding. 3 and a 2. Let's see here. In order for me to create a positive 7, this needs to be positive and negative, and I still get a negative 6. So x equals 3 over 5 and negative 2. Now, let's see which one of these isn't going to happen. If I plug negative 2 into this thing, I get a 0 on the bottom. Is that okay? It is not okay. So negative 2 does not work. Jared, is that what you're going to say? Yeah. Okay, cool. Try, dude. You're a very anti-Scott. Okay, that was 63. 76. Ah, yes. We don't have that. That's Teacher Mariano right there. Okay, when we have a problem that looks like this, I have a base of 25 and a base of 5. I'm going to try and create a base of 5 every single time. So 25 is really 5 squared to the x. And that's going to equal 5 to the x squared minus 15. And now, since my bases are the same, I'm going to go ahead and set my exponents to be the same. So I'm going to subtract 2x from both sides. So what I get is x squared minus 2x minus 15 equals 0. Let's go ahead and factor this. X equal, oops, not x equals, x and x. Looks like it's going to be 3 and 5, negative, positive, so x equals negative 3 or 5. Yes? Yes? All right, so that was number 76. 98. Yes, excellent problem. And I missed something. Sorry, this is not 1/2. This is 1/2 log base 4 of that. Sorry. Right. First thing I'm going to do is I'm going to back these things in. Using my reverse properties of logarithms, this is really log base 4 of x plus 2 to the 1/2 power plus log base 4 of x minus 2 to the 1/2 power. And that's, did I write this down correctly? Okay. Equals log base 4 to the 27th power to of 27 to the 2/3 power. Okay. Yeah, Aaron. Okay. Let's see. The cube root of 27 is 3. 3 squared is 9. So this is log base 4 of 9. Yes? And that equals log base 4 of x plus 2 plus log base 4 of x minus 2. And these are all to the 1/2 power. Okay. So here's what I have. This is something a little complicated. Because all the log bases are 4, they can all go away. So I have, and because there's addition happening, what's happening to my answers? They're being multiplied. So what I have is the square root, one big square root of x plus 2 times x minus 2 equals 9. Yes? So now I have the square root of x squared minus 4 equals 9. I'm going to square both sides. I got x squared minus 4 equals 81. I'm going to add 4 to both sides. I got x squared equals 85. Take the square roots. X equals plus or minus rad 85. Yeah? That was a little bit of an involved problem. I have a funny feeling about that problem. Anyone want to check the answer key and see if that was correct? Sorry, you're right. So it should just be x equals rad 85. Right, can't be minus because of inside the square root sign. Oh, sorry, inside the logarithm. That's kind of that problem was trickier than I thought it would be. All right, 100. Okay, similar problem. Log base 6 of x squared plus 2 plus log base 6 of 2 equals 2. I'm going to use my reverse properties of logarithms to multiply these two together. So I have one singular log base 6 of 2, parentheses x squared plus 2 equals 2. When we're stuck in a logarithm, what do? Change forms. This is 6 squared equals 2x squared plus 4. This is 36 equals 2x squared plus 4. Subtract 4 from both sides. 32 equals 2x squared. X squared equals 16. X equals plus or minus 4. Now this time, can we keep both of them? Yes, we can. Will, do you know why we can keep both of them? Because we're going to square it eventually. Good. Very good. So with 112, you got to use change of base formula. So that is going to be log base 8 of 15 is natural log of 15 over natural log of 8. Who can raise your hand and tell us? Aaron? 23. Ace, pump it into your calculator. Okay? That's a piece of cake. 196. Yeah. Yeah. Oh, sixth term of 2x plus 3y to the 8th. Okay, so for this one here, you need to use your sigma notation. Remember this thing where n is up here, k starts at 0, and it's n factorial over n minus k factorial times k factorial. And then it's going to be x to the n minus k, y to the k. So, since we're trying to find the sixth term, or let's go ahead and identify the first thing first. Anyone remember what is n in this problem? Joshua? N is 8. Anyone know what k is? Anyone know what k is? K is always one less than the thing that they're asking of you. They're asking you the sixth term. In this case, k is going to equal 5. So now we just pump all this stuff in. So it's going to be 8 factorial over n minus k, so 8 minus 5 factorial, and then k factorial 5, so that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, over, this is 3 factorial, so that is 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. Those get out of there. These two get out of there, so you end up with 8 times 7, which is 56, right? And then, so it's going to be 56. Let's see here. And then it's going to be x to the, sorry, so it'll be 2x to the n minus k, so that's 2x to the third, times y, so that'd be 3y to the k fifth. Okay, so I need someone with a calculator. This is 8. 3 to the fifth. I need someone with 3 to the fifth. 243? Okay, I need someone to do 56 times 8 times 243. 108,864. X to the third, y to the fifth. Duh? It's yes in Russian? Okay. There you go. All right. 120. Oh, yes. Yes, we can. Okay. For 120, I'm going to need your help with some calculators, okay? So it's 5 to the 2x plus, crud, that's awful. So it's 5 to the 2x plus 5 equals 4 to the 3x minus 2. Now, unlike some of the other ones where you could manipulate the base to look the same, right? We can't do anything. So in these cases, what we do, Amrit, is we take the ln of both sides. So what we get is ln of 5 to the 2x plus 5 equals ln of 4 to the 3x minus 2. What I'm going to do, Amrit, is I'm going to take these things down this way. So I end up with 2x minus 5 ln 5 equals 3x minus 2 ln of 4. Is it plus 5? Sorry. Thank you. So far, so good? Now we're going to go and distribute this in. So what I end up with is 2x ln 5 plus 5 ln 5 equals 3x ln 4 minus 2 ln 4. So now I'm going to go ahead and move this thing over. I'm going to go and subtract 3x ln 4 from both sides. And then I'm going to go ahead and move this over, Amrit. Okay? So I end up with 2x ln 5 minus 3x ln 4 equals 5 ln 5. Looks like minus, or sorry, negative 5 ln 5 minus 2 ln 4. From here, I'm going to factor out an x. So I get 2 ln 5 minus 3 ln 4 equals negative 5 ln 5 minus 2 ln 4. It is starting to come back. And now we just divide by the big thing, and then divide by the big thing. Okay. So you get x equals, and then you got to use your calculator to figure out what negative 5 ln 5 minus 2 ln 4 divided by the big thing is. Yeah? Cool. All right. Let's go ahead and stop right there for a second. I'll give you guys some more time, and then we'll come back in a little bit. Okay, so with this one here, I'm going to first flip the bottom and factor out a negative 1, so that is negative 3x squared plus 3. And then I factor out a negative 3 rather, so it's x squared minus 1. Okay, and then this is a 4 on top. And so since it's minus here, and then I have a 2, and then x squared plus 5x plus 4, everyone okay with this? The negative becomes positive. Yeah, and then this thing kind of goes away. Right? In fact, I can just kind of do that. All right. Everyone okay with what I just did? Cool. Okay, so now I'm going to go ahead and factor everything. So this is 2 over x plus 1 times x plus 4 plus 4 times over 3 x plus 1 x minus 1. I need a common denominator here, which is going to be x plus 1, x minus 1, x plus 4, and all of that by 3. So now I got to figure out what's missing. Well, what's missing on the left is a 3 and an x minus 1. I am missing an x plus 4 on this side. So what I get, bless me, thank you. I get 6 times x minus 1 plus 4 times x plus 4 all over my common denominator, which is 3 x plus 1, x minus 1, x plus 4 equals 6x minus 6 plus 4x plus 16 all over the common denominator, which equals 10x plus 10 over 3 times x plus 1, x minus 1, and then x plus 4. Okay, now with this one's kind of unique. I can go ahead and factor out a 10 here and get x plus 1, which means the x plus 1s can go away. So I end up with 10 over 3 times x minus 1 times x plus 4. That rarely happens, but when it does, it's actually kind of cool. Yeah? Okay. All right. Let's see here. Let's go ahead and erase more. All right, so that was 54. So 68. Let's mark that off. 68. Yes, 1/9 plus 1 over 2x equals 1 over x squared. So I believe my common denominator here is going to be 18x squared. So I'm going to multiply this by 18. This thing here is going to get multiplied by 9x. Sorry, 9x. And this thing here is going to get multiplied by 2x squared. So what I end up with is 2x squared over 18x squared plus 9x over 18x squared equals 18 over 18x squared. Now I have all common denominators and I'm solving an equation. Those can go away. 2x squared plus 9x equals 18. I'm going to go ahead and subtract 18 from both sides. So I end up with 2x and x. Let's go with 9 and 2. That is 4, and that's 9. That's not correct. 6 and 3. 12 and 3. Yes. So I'm trying to create a positive 9, so that's positive and negative. So x equals 3 over 2 and negative 6. Let's see if any of those give us problems. None. None give us a problem. So we're good. All right. That was 68. 90. Who asked for this one? Who asked for 90? Anybody? Nobody. So we're going to skip this one. Is it really that hard? They cancel each other out. X squared plus 9x equals 10. So x squared plus 9x minus 10 equals 0. X minus 1, x plus 10. X equals 1 and negative 10. Which one of these works? Which one of them doesn't? Both of them work. Right? Because you're squaring the negative. Yeah, Jared.
What if you have a negative that isn't squared?
Then it can't be put in because you can't have a negative answer in your logarithm. So that was number 90. 177. Oh, I believe this is... Who asked for 177? And then who asked for 178? Okay, so I think once we get 177 down, I think 178 will be easy. So we're trying to do 0.12121212 dot dot dot. Okay? So a sub 1 is going to be 0.12. A sub 2 is going to be 0.0012. A sub 3 is going to be 0.000012. What is R? Andres?
0.001.
Not 0.001. 0.01. Can we get a confirmation on that on a calculator? Go 0.0012 divided by... Jared?
So how do you find the R?
Oh, take this thing divided by this thing. Joshua?
Divide A2 by A1?
Yeah, divide A sub 2 divided by A sub 1. Yeah? Okay, so if this is R, then what we do is we use our infinite sum formula to say A sub 1, which is 0.12, divided by 1 minus R. And that's 0.12 over 0.99. So that's 12 over 99. They can both divide into 3, so it's 4 over 33. Serena, do you know how to do number 178 based on this? Okay, cool. 195. Okay, we are trying to find the third term of x plus y to the 8th. So again, we bust out this formula here, summation of n, and then k starts at 0 of n factorial over n minus k factorial times k factorial. And then it's x to the n minus k, and then y to the k. So what this translates into, Will, is n equals 8. K equals, since we're looking for the third term, Will, k equals 2. Okay? So what I do is I pump all this stuff into the formula here. So I go 8 factorial over 8 minus 2 factorial times 2 factorial. And that's going to get multiplied by x, because that's my x term here. n minus k is 6 y to the k. Yeah? Okay. So what this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, this is 6 factorial, so it's 6 times 5 times 4 times 3 times 2 times 1 times 2 times 1, right? Because of the other 2 factorial. That's gone. That's gone. This becomes 4. 4 times 7 is 28 x to the 6th y squared. Jared.
What if you just like
Expanded the whole thing?
Yeah.
That's fine.
and then
More work for you. But yeah. Okay. Cool.